mention on Friday the notation that they use for conjugate pairs. So maybe just in this heading, oh dear. So if you have here Z equals A, I'm sure they'll take it on now. Z equals A plus BI. Then the notation for the conjugate is an asterisk, like that. So if you see that, you need to know immediately that refers to the conjugate. So if the original complex number was A plus BI, then the conjugate is going to be A minus BI. Right, remember the same two terms with a different sign. Oh dear, guys, we did a whole note on this on Friday. If you don't know what I'm talking about, you weren't paying attention on Friday, so that's good enough, I think. I gave you the date the other day from the 11th of March. Yeah, it's here. No, next week. And then, 14. But our tax on, we get our tax on the 1 Thursday. Oh my goodness. Okay. Right. Your class is being handed out on Thursday. It is being due the following Thursday. In the Monday after that, you spoke about it. Okay. We are doing arithmetic with complex numbers today. So that is the new heading. Okay, arithmetic has basically just like operations, right? So we're going to add and subtract them, we're going to multiply and divide them. Let's see how that works. So addition and subtraction. Okay guys, so we're actually just going to do some examples. It's pretty straightforward. Write all the information down, given the complex numbers. Oh really, what else? Upstairs, leaf blower, Jesus. So W is 2 minus 4i, and Z is negative 1 plus 3i. Those are the two complex numbers that we're going to work with. And the reason why they are given names is so that in a calculation I can just say what is W plus Z. Okay, so that is the first one that we're going to do. Right, that is a question. So now, obviously, we're just going to write what W actually is. It's 2 minus 4i plus Z, which is, guys, I'm just going to put this negative 1 plus 3i in brackets just because there's a minus in front of that one. Okay, but I suppose you could just write a minus 1. I just don't really like how that looks. It's my own. Could even close your brackets there if you wanted to. because there's a plus and a minus. Yeah, it's just nice to have a bracket there. And I'll differentiate between the two. But what do you think we're going to do here? And it's not a trick question, it's just this. Yeah, so basically we're going to like add like terms in a sense, right? So we're going to add the two real parts. Remember that I told you guys that a complex number consists of a real part and an imaginary part. We're going to add the real parts together and the imaginary parts together, and that's it. Okay, it's really not difficult. So we're going to say 2 minus 1 is just 1. And then we have negative 4i plus 3i, which is negative I. And that's the answer. Yeah, it's as simple as that. Basically just adding and subtracting like terms. They can make it slightly more complicated by doing something like this. We need to find w minus 2z. It's a little bit more complicated, but it's also not that bad. So now w is the complex number 2 minus 4i. And we are subtracting 2 times z. But z is this complex number. Okay, so 2 times z. Just like that. What do you think I'm going to do next? So multiply the negative 2 into this bracket, right? So I'm going to say, I'm going to keep my 2 minus 4i as it is. Hello, oh yes, I'm just from next door. Okay, where is it on the seat, guys? I think it's just the oh, it's good one. The one that I was using it as a I see that. So you got baptism of fire, how's that? Okay, I'll try to be also with three and everything. You don't want to give, we haven't even spoken about the colors, so thank you. I'll keep that in the same place. Okay, yeah, maybe just pay attention for today, all right? Because I record all of my lessons so they are on the class and we'll get through them. Okay, just, yeah, don't worry about taking down notes for today, just listen to what I'm saying. Okay, w minus 2 times z. All right, so w is this complex number, 2 minus 4i, minus 2 times this complex number, and now we're just multiplying the negative 2 in, right? All right, now guys, negative 2 times negative 1 is what? Positive 2. Oh, good, sir. Negative 2 times negative 1 is positive 2, right? And now we're going to say negative 2 times positive 3i is minus 6i. And so following, guys, I just multiplied a negative 2 into the bracket, right? Guys, it's even with lots, but it's almost like we're doing algebra. Okay, and the I is like an X. That's actually what we're doing. Okay, now we just need to add like terms together. So 2 plus 2 is 4. And negative thank you. And negative 4i minus 6i is negative 10i. That's the answer. Now guys, they can ask you more things here, all right? I can ask you, never mind, I'll do that later. Never mind, I don't want to complicate things. I mean, you are, but you don't have. No, I know, but I'm like, because it's I. I kind of forgot what the I is. I is the squares of negative 1. Oh. Okay, guys, calculate that on your own, please. W with an asterisk means the conjugate of W. So it's not negative, guys, it's just the same two terms. What sign is in between those two terms in W? A minus. So for the conjugate, you're going to change that to a plus. That's it. I think that's a sign in between. And then minus 4 times z, and then we just put your like terms together. Did you say something else? It means the conjugate of W. So the same two terms, but with a different sign in between. There you go, there's my answer. Can anyone consider? Which minus 8i. Alright, so now the conjugate. W is 2 minus 4i. So W star conjugate is 2 plus 4i. Okay. You actually will get a mark for doing that. This was a question in a test. Right, minus 4 times z. So now we're putting in z, which is that complex number there. Next step, you multiply a negative 4 in, and then you simplify. Okay, any questions on that, guys? You're fine? Okay, let's look at multiplication. Okay. Is it just? Toilet. Toilet. Oh, yes. Sorry, I heard something different each time and it wasn't toilet. I don't know. Yes, okay, guys, let's work with, it's actually the same too, but I'm just going to rewrite them. Sorry, it looks like I wrote W and Z only for this next part. Let's just rewrite them. We are going to again just be working with W, which is 2 minus 4i, and Z, which is negative 1 plus 3i. Now we are going to multiply them together. All right, so for A, we are going to do W times Z. Now guys, W essentially is 2 curves, right? And Z also is 2 curves. So I'm going to have to put them in brackets and write it like this. 2 minus 4i times negative 1 plus 3i. And if those i's were x's, you would know immediately what to do, right? You would just spoil them off. Okay, so that's what we are going to do. We're going to say 2 times negative 1 is negative 2. We're going to do our alphas. 2 times positive 3i is positive 6i. Negative 4i times negative 1 is plus 4i. And now for this last term, we have negative 4i times positive 3i, negative 12i squared. Remember, what is I? The square root of negative 1. So what is I squared? Negative 1. Right? It's coming from this. I is the square root of negative 1. That is the definition of I. So now when we square that, then we take the square root of negative 1 squared to get negative 1. So guys, whenever you see I squared, you're going to replace that with a negative 1. Okay, so I'm going to put it in as a separate step. You don't have to. You can actually just go straight to the answer. We have a negative 2 here. What's 6i plus 4i? 10i. Now this negative 12 times negative 1 is what? What's negative 12 times negative 1? Positive 12. And now we just have some more like terms to sort out. What's negative 2 plus 12? 10. So the answer is 20 plus 25. That's basically how you multiply complex numbers together, guys. I'm just going to give you one to do on your own quickly. Now we are going to do W times Z conjugate of Z. Do that one on your own, please. Oh no, just the sign in between. Okay, are we done, guys? W times the function. Has it been a long day?
It's been a long week.
Don't look straight.
It's been a
I'm
long
not straight, okay? I'm typical. We have to answer it.
It's already.
What? I'm like, that's It's only Monday, yes. There we go. That's it. W times the conjugate of Z. Conjugate that Z was -1 plus 3i. Conjugate is -1 minus 3i. Don't change all of the signs, guys. You just change the sign in between, okay? So that plus there becomes a minus there. Yes.
We only do conjugate of a complex number.
Now we are going to work with it in this more complicated algebra going forward. Yeah, it is quite a useful thing. Okay, guys, so then you will go to brackets out and simplify your plus 12i squared. Now we remember that I squared is -1. So 12 times -1 is -12, -12 there, and then you get that. Yes? I feel like you guys are feeling a bit unsure about this, but it's like just
It's just the end of a
okay,
language.
okay, just next week or something, if I would like that. Just sit. Thank you, Daniel. Just sit and just breathe and just look at this. It's not that bad, right? Please. I see very blank expressions, okay? It's just okay. Just do this and then that and then we're fine. Okay. Yes.
When oh, you automatically sign us up for the mathematics together.
Yes, if you are in the top set, you are in the maximum set, you are right on it.
Okay.
Oh no, let's not get sidetracked.
On the
Keep
end
doing this
part.
now, okay? You just sidetrack more.
Sorry, man.
Okay, division. Division.
I'm gonna zoom in a little bit. This seems a bit small.
That's fine, man.
It's already done. Sorry.
Okay, guys, now for division, it's a bit more complicated. Okay, again, we are working with W, which is 2 minus 4i, and Z, which is -1 plus 3i, and guys, in a complex number question, they will tell you what the complex numbers are. Okay, so just like I've written there, I'm not saying that W is always 2 minus 4i. Okay, I'm thinking now maybe it looks like that. W for these examples is 2 minus 4i, but in the question, they will tell you what your complex numbers are. Okay, they can use different letters for this W and Z stuff. They can use A's and B's, whatever. X's and Y's even, all right, and they will tell you which numbers you need to work with. Okay, so it's not something you need to memorize, they will tell you. So guys, when we are calculating W divided by Z, I'm just going to write 2 minus 4i over -1 plus 3i. That's division, right? Division is a fraction. Okay, so if you're saying you divided something by something else, you can write it as a fraction there. But guys, what I want you to recognize is that we have 2 terms over 2 terms, right? Meaning that we can't just say, okay, I'm now going to divide the real part and the imaginary part. Unfortunately, that's not going to work in this case. Because if you are dividing 2 terms by 2 terms, you're supposed to divide both terms at the top by both terms at the bottom. That's why I always make a big thing about You're not allowed to cancel out if you have more than one term. Now, when we just did algebra in 4, how did we sort that out? How did we go from more than one term to one term? Someone else? Someone else? How did we go from multiple terms to one term? Okay. We factorize. Does it look like we can do that here? No. At the top we could, but it's not gonna help us.
Not really.
Right at the top, if we take out a 2 the common factor, is that gonna allow me to then actually cancel anything out? No. Right, so guys, when you are working with complex numbers, there's actually a trick. Okay, that I'm going to teach you now. And this trick you can use in other sections of maths as well. When it comes up, I will just remind you of this. But essentially, we've hit a dead end. Okay, we can't actually do anything there. We can't simplify that. So what we are now going to do is we are going to multiply the top and the bottom by the conjugate of the denominator. And I'm going to write that down. The denominator is z, right? I'm going to multiply the top and the bottom by the conjugate of z, and you'll see why I'm doing that. So I'm going to multiply the top and the bottom by -1 minus 3i. Take a note. Multiply top and bottom, or you can write numerator and denominator if you want to. Sorry, that's interesting. By the conjugate of the denominator. And guys, today I did this with my matrix in trig. Alright, where we got to a fraction, a trig fraction, we couldn't do anything, so we multiplied the top and the bottom by the conjugate of the denominator, and that gave us some opposite square. Okay, so it is going to come up a lot still in future. Now, guys, we're going to have to do 2 foils here. We're going to have to foil these ones out, and we're going to have to foil these ones out. What I want you to notice here at the bottom, does this maybe look like a product that we have a shortcut for? Right? We have the same 2 terms, but a different sign in between them. So when I foil these 2 brackets, it's going to give me a difference of 2 squares. Am I right? So that's going to give me at the bottom. Remember when we do that, the difference of 2 squares is going to be the first term squared. Now what's -1 squared? -1 times -1 is 1, hey? Then minus, what is 3i squared? 3i in brackets squared? -9i squared, okay? I'm just going to write it on the side.
+9.
No,
But it's I squared.
oh yeah, sorry, oh yeah. Sorry, I thought you made question that be a +9. Yes. I just don't want to do too many things at once. Yes. I'm just finding out. I'm just going to do it on the side here for you. We did do this as a shortcut in 4, and you guys were all very confident in this. Maybe now because there's an I in the mix, you're not feeling so confident. Let's just foil this out quickly. -1 times -1 is 1. When we do our outputs, -1 times -3i is +3i. 3i times -1 is -3i. Then you do your last. +3i times -3i is -9i squared. Right, but then 3i minus 3i is 0. So that's where this is coming from, guys. That's that shortcut that we did in 4. Right, if you see that we have 2 brackets that we multiply together, in those brackets you have the same 2 terms, just with a different sign in between them, then you can apply this difference of 2 squares shortcut. If you don't want to, guys, nothing's stopping you from just foiling it off. Right, you can do that. We have to do that at the top anyway, so we have to foil these brackets off. 2 times -1 is -2. After 2 times -3i is +6i. -4i times -1 is +4i. And now when we do our last, negative times a negative is a positive. 4 times 3 is 12. And I times I is I squared. As I'm sensing that you guys want to skip the step where you're writing I squared. That's okay, but you might be setting up a trap for yourself, okay? Because with lots of signs and stuff, just rather write it down. Yeah, at the top, are any of these going to cancel off? Here? No. Positive 6. Oh, it should be negative 6. Yeah, sorry. Thank you. What? Thank you. I was just checking to see if you're awake, and Erin is pretty clear that you're the only one. So wait. I don't know jokes, man. You're not even laughing at my jokes today. Oh, great. Thank you. Okay, so we have negative 2. Now we have negative 6i plus 4i. That's negative 2i. Now I'm going to write, guys, that this is going to be positive 12. I'm going to do negative 12.
So like confident.
A for confidence. At the bottom, 1 minus 9 times negative 1. That's going to be 1 plus 9. So you can write the name straight away. It's fine. Okay. Okay, now let's just simplify. Negative 14 minus 2i over 10. Now, guys, usually in a textbook exam, or even in a textbook, they'll say that you have to write your answer in the form a plus bi. Okay, they don't actually want you to leave your answer like this. They do want you to have 2 separate terms. So that you have your real part and your imaginary part. And I can split this fraction up, right? Because it's 2 terms over 1 term now. You see that? So I can split that up quite easily. Again, you can do this in one step, the whole splitting up and simplifying thing. But I'm not sure if any of us are capable of doing it today. Oh, you see what I mean? That must be a 10, sorry. So I'm just writing each term over 10. Yeah, it must, if they're writing in the question a plus bi, you have to put the a part, the real part. Yes. Okay, what's 14 over 10? 7 over 5, right? Okay, so negative, yeah, 7 over 5 minus, that one is going to be? I over 5. So you can write I over 5. Some people prefer to write it like this, negative 7 over 5 minus 1 over 5i. Doesn't matter. It's fine to do the same thing. It's up to you. And I just want to come back to this trick. And firstly, why I'm allowed to do it, and secondly, why I'm actually doing it. So guys, if you are multiplying a fraction, right, by the same thing at the top and the bottom, if I want to simplify this, what is this bracket divided by itself? 1. This is actually 1, okay? If I multiply the top and the bottom by the same thing, what I'm actually doing is I'm multiplying the fraction by 1. And that multiplying anything by 1 changes value. Oh, right? 2 times 1 is still 2, okay? But if I say 2 times 3 over 3, it's going to be 6 over 3. So it's still going to be equal to 2, but it's going to look different, which is what we're doing here. I'm multiplying this fraction by 1 essentially. So if you want to, you can just use a different colored pen. Let's use a light blue one here. Just going to circle this. This is actually equal to 1. If you multiply anything by 1, that's not going to change the value of it. But we are multiplying this fraction by 1 in a clever way, right? We are multiplying it by 1 made up by these, or made up of these 2 brackets, so that the i's are going to go away. All right? I started with a negative 1 plus 3i. I wanted to get rid of I completely. I just wanted something like this. I wanted my denominators to not have i's in them anymore. Do you see that? That's what we ended up with in the end. You can look at this as well. So guys, the only way to do that is to multiply this bracket by its conjugate so that the 3i and the minus 3i are going to cancel out. And I'm going to be left with an I squared, which is just negative 1 anyway. Okay? So that is why I'm doing that, guys. That's why I'm multiplying the top and the bottom by the conjugate of the denominator so that I can get rid of all the i's in the denominator. Okay, I'm going to let you guys practice one on your own now. So do the conjugate of Z over 2 minus W. Yes. Yeah. I'm actually isn't working on that. Okay. I'm just gonna let you guys do the first step. Don't multiply by anything yet.
What do you mean?
Have you done the 2 minus W? And what is it?
2 minus.
That's for I, okay? Alright, I'm doing in my lines. Is going to do that now? No? Has W consists of 2 terms, so when you subtract it, you have to put those 2 terms in brackets. Make sure that you're doing that. You're saying 2 minus 4i, right, in brackets. Now, when you actually simplify that, this is going to be 2 minus 2, right, which is just 0. And a negative times a negative is a positive 4i. Sorry, I didn't realize that when I copied down the example here, but now do we actually have 2 terms in the denominator? Okay, no, we just have 1. We can write it as 2 terms if we wanted to, right? But guys, now remember what was the question of multiplying the top and the bottom by the same brackets? We wanted to get rid of the i's, all right? Now do I have to multiply by something very complicated to get rid of the I over here? What do you guys think? What do I actually need at the bottom for there not to be an I anymore, just numbers? We could do that, but what about just an I? What if I multiply the top and bottom by I? What am I going to get at the bottom? 4i squared, right? Which is just a number. We can do that. Okay, so we're trying to use these guys. Okay, so if we multiply the top and the bottom just by I, that will also work. Remember that the purpose of multiplying the top and the bottom by something is to cancel out the i's. Get rid of that I there at the bottom. So now if we do that, I'm going to have, what's negative 1 times I just? Negative I. And negative 3i times I is negative 3i squared. What is 4i times I? 4i squared. Because that's all I need to multiply by in order to cancel, to get rid of that I in the denominator. And I and I equals 1. Yeah. Then I will still left with an I. So it's fine to have an I in the numerator. We have one here as well. We just don't want an I in the denominator. That's the thing. Okay, let's just simplify these quickly. We have negative I. What is I squared here? That's the same as negative 1. A negative 3i squared is the same as plus 3. Now what is 4i squared? Remember, I squared is the same as negative 1. What's 4 times negative 1? Negative 4. So you see guys, just by multiplying by I and the I did get rid of those i's, the I in the denominator. Now, if that doesn't make sense to you, as I say, you can multiply by negative 4i, you will get the same thing, you'll just have to do a bit of a more complicated simplification at the end. But that's fine, guys, let's split this up. Let's write it in the right form. We need to have a plus bi. So what is the a part? What is the real part of this fraction? The 3 over the negative 4. Can I write that as negative 3 over 4? Is that fine with you guys? I'm splitting up that fraction, right? And I'm just putting the real part first. So that's how they want to answer. And the imaginary part is going to be negative I over negative 4, which is what? Plus I over 4. Or you can write it like this, -3/4 plus 1/4 I. I'm just going to freeze quickly so I can draw in all my lines there with the ruler. Just hang on. Okay, that's better. So guys, I'm just going to circle this here. Again, this is equal to 1, which is why we're allowed to do that. Okay, we can multiply the top and the bottom by the same thing. You guys, by the way, that's why in like grade 6 or grade 7 or whatever, when you need to write two fractions over the LCD, you multiply the top and the bottom by the same number. Right? Because when you multiply the top and the bottom by the same thing, you're actually multiplying it by 1. I don't think they explain that to you in the lower grade. They always say, right, if you do something at the bottom of the fraction, you must do the same thing at the top. But this is why. Because when you multiply a fraction by the same number at the top and the bottom, you're actually multiplying it by 1. And that's actually why. Anyone hear that much buzzing? What is it?
I don't get you.
Very irritating. Eye of the eye is yeah, not the whole thing, just the eye of the eye, just the blue part that I said. Okay, now guys, I just want to add here to this little note. We have 2 times top and top and bottom by I'm just going to say something, all right, because in this case it was just a 1 term, it was just an I, that will allow us to get rid of the I in the denominator. So if in your denominator you have 2 terms, like we did in the first example, we're going to multiply by the conjugate of the denominator, which is what we wrote in the first example, okay? If you only have 1 term, and that term has an I in it, you just need to multiply by I. Because if you're multiplying an I by an I, that's going to give you I squared, which is -1. Okay, so essentially that I you can turn into an I squared, so that it's just. Okay, guys, I think it's time for you to do some individual work. So exercise 3.2. Did you just say never mind? Yeah, this is only due for Okay, number 2, which is just adding, subtracting, multiplying, dividing, the stuff that we practice now. But then I want you also to do 4A and B, which is a bit of problem solving work. All right, in AB, I'm not always going to tell you exactly how to do a question before you get it. In 4A and 4B, they've given you an equation with an A and a B in both equations, or that's the two variables, and they're saying you must solve for those variables to make the equation true. So you can take a look there. Okay, start working on that now, please, great kings.